Any question? Any question? So far so good? No question? Alright, so let's execute the program again. For example, I want to get information about student B. What happened? Student D. Do we have a student D here? No, we don't have a student D. So what happened? So for example, I enter student D, and then it's a runtime error because we don't have a student D. So to avoid that, we need to check student D in our data set yet or not. Alright, so how to do it? So let's see if student name if they are in our data set here, it means it's in our dictionary. So we're gonna do on the operation here. How about else? If the student D is not in our data set, we do nothing. Alright, we just print student call student name not in our data. Alright, let's give it D. So we see that you need to check. So this one we call test here. Right. So okay, how about delete student? If you want to delete it, it's so easy here. After I read out information about student, I'm going to delete it. So you can use del function to delete it. This student name here. Alright, after I delete it, I'm going to read it down again. Oh, no, here. Alright. Oh, I don't need to import again. Just one time is enough. Alright, let's read down the information about student C. And at his birthday, let's say he was born yesterday. Alright. Okay, so you can see that you see before we delete, so student C have birthday here. But after we delete here, we lose student C. Alright. Okay, that's it. It's so easy. So we have another information we call key here, keys. It means it return all the keys inside dictionary. So in our example, we read now all the student names. Alright. And similarly, we have a values function. It will return all the values inside dictionary. Okay. So the most important thing is keep in mind that values, you can use any kind of information to be a value. It can be a non-dictionary, it can be a list, it can be a number, it can be a string. So you can use all the data type as a value, and similarly for keys. Alright. But usually for dictionary, we're going to use string to become a key. Alright, this is the most common way, the most popular. Alright, so let's see what's the difference between dictionary and list. So keep in mind that list, they have an order. Alright, what does it mean order? What does it mean order in list? List has order, but dictionary doesn't have order. Let me show you. Alright, so far so good. So we don't need the rest of them here. Then I turn it off. Alright. So let's talk about a list. So we have a list A, have an element A, B, and C. We have a list B, have element similarly B, A, and C. So what happens if I try to compare list A and list B? What's the output? True or false? True or false? Any idea? Please. What do you think? True or false? You don't know? False? Alright. How are you? True or false? False? False. Why false? How are you? True or false? False. Yeah, why? The order, yeah, that's it. Yeah, the order. So, because even though they have the same element, but they are different order. Here, A and B. So, let's compare A, no. When you compare two lists together, they compare the first element here to the first element here. And they see they are different. So that's it. They conclude it's different. So we're going to read out false. Just false. Right? However, when you have a dictionary, take one this A here. We have A, key A, value is 10. We have the key B, value is 3. And then we have a dit. Oh. So A here is, no, let's see B here. B first, alright, B first is equal to 3. And A equal to 10 here. So see that? They are exactly the same values and keys, but the order are different. Alright, so we will now let's compare them together. Alright, let's see. Yes, it's true, even though they have a different order. Alright, it means the order is not important in dictionary. And you can read it home. But keep in mind, dictionary is dictionary is mutable. Alright, it's not immutable, it's mutable. Okay, let's talk about set. Alright, so set is similar to dictionary, but set doesn't have a value. It just has a key. So for example here, you have a set here, Alright, we have a key here, apple, banana, and cherry. You don't have a value, just key, right? So you can read now using len function here to read now how many elements you have in a set. However, a set is an index. What does it mean, an index? Example. Alright, so we don't need it anymore. So for example, I have a set A here. So I have a 3 element here. Banana. I have let's see, apple and lemon. Alright, if I read now set A, I want to get the first element. So it means I give index 0. Yes. Let's see. Here. It's a runtime error because you cannot use index to accept a set. A set is an index. Alright. To accept the set, Alright, how to access a value set? How to access access to a set? How? You have only one option. That is you use for loop to go through every element in a set. Alright. For here, let's say item in set A, and right now item here. See that? So read it out. Here you get all the elements. Alright. So the question is why you need a set? Why? What is the application of a set? Before we talk about application, talk about the comparison. So I have a set A here, and I have a set B here. They have the same element, but I'm gonna change their order. Alright. So let's see what happens if I read out set A compared to set B. What do you think? Joe? Yes, you are right. It's true. Order is not important in a set, right? Alright. So next question is why do we need set? Why? I'm gonna show you example. Let's talk about in operator. So for example, I have a list here. Oh, so far so good. Let's turn off the code here. So I have a list A here. So I have a number, for example, number 10, 2, minus 7. So I want to input a target here. Enter a number, any number I want. So in here, let's see. If the target, we need a target here, in list A, so I want to read now 2. So otherwise, I will read now for false. Alright. So how can I do that? So easy. Just read now here. Print target in list A. That's it. Alright, so if target is in list A, they will return true. Otherwise, they will return false. Alright. Let's see. I want to enter number 10. Alright, 10 in our list here. But if I enter 12, it will be false. Alright. So the question is, let's assume I have around 1 billion elements. 1 billion. Alright, I will create a list. A list contain 1 billion elements. 1 billion. Alright. I'm not sure this computer can execute this example, but let's see. Alright, I want to have a list 1 billion, rank 0 to 1 billion. Is it 1,000? A million, and then we have 10 million, 100 million, 1 billion here. Alright. So I want to enter a binary number, and I want to check here. But I want to know how long this operation take. Alright. So how long this operation take? Alright. How long? So to do that, I'm I'm gonna import a module time here, and then I have a store here, time dot store. No, I'm sorry, time dot now, and end. All right. So read now duration, for example, end minus stop. All right. So let me scale. Oh. It's die. It cannot do it. All right. So let's reduce to 100 million. All right. Now it is too much. Let 10 million is not. No. Okay, it's good. I want to enter, for example, 500. This function is not exist, so maybe I remember wrong here. Time not time, for example, time, alright. 500. So we got about 0.006. It's around here. 0.1, 2, 3, 4, 5, 6 here. Second. It's not bad. However, I want to scale 1,000 similar operations. Alright. So I do not enter from the keyboard anymore. I'm going to use a loop here. So for target in range, I want to short any number between 1,000 and 5,000, for example. So it means I'm going to execute this operation 5,000 times. So let's see how long it's going to take. Execute it and wait. Oh, I don't want to get it out. I'm sorry. I'm sorry. Let's tie it up. I don't want to read it out. Just check it. Alright. Let's see result equal here. I just want to know how long they're going to take. Alright. Let's see. 0.6 seconds. However, I want to increase the number to 20,000. Alright. Let's see. It takes a long time. So we have 15 seconds to execute this operation 20,000 times. However, I will change this one to a set, not a list anymore. Change to a set. Change to a set here. And let's see how long it's going to take. Remember this number, 15 seconds. Alright. Let's write it down. 15 seconds. And scale again. Here you see that 0.03 seconds to do the same, exactly the same operation. Alright, for the set. So in set, when you want to short something, set is faster. Alright. So let's see another application of set. So far so good. Let's turn it off the code. Alright, if I have a list A here, 10, 4, 10, 5, 5 for example, 10, 7, 8, 7. So we have a duplication. Here we have a 10, 1, 2, 3, 5, 3 times 10. Similar, we have a 5 here, we have 7, 7. I don't want duplication. I want to remove all the duplication. How can I do it? It's an example. Just convert a list to a set. Let's see here. If you bring a list A, you're going to see duplication. But I convert list into a set here. So let's see. So see that it's remove duplication. No duplication, because each element of a set is unique. You never ever have a duplication in a set. Alright, keep in mind that. So after you convert a list to a set, you can convert it back to a list. Yeah. So you see that this one is here, the symbol different here, because they are different data structure. But I can convert a set back to a list. You see this one? Right. Alright, that's the only information about dictionary and set. You need a lot of time to practice this one, dictionary and set, because actually they are the advanced data structure. But actually they have a lot of application in real project. Alright. So maybe when you do a real project, you're gonna know how to use it better. Alright. Okay, that's it for. Let's talk about algorithm. So today I'm gonna review. No, not review. I just review some kind of algorithm. We call it guess and check. So what does it mean, guess and check? Then I provide a short description. So sometimes you want to find solution for a problem, but you don't know how to find it. So the most simple way is guess it. Guess a number and then check it. So if the answer is correct, so you got the answer. But if the answer not correct, so you're gonna try to guess a new answer. Alright. Somebody confused? Okay, so let's get back to square root. Square root example. So for example, I give you square number 9. So you want to find square root of number 9. What is the square root of number 9? What is square root of number 9? 3. Yeah, that's it. Yeah, right. So how you can find using coding? The most easy one is using guess and check. Alright. Alright, so let's see. We're gonna find we're gonna find square root of a number. Alright. So let's enter a number first. This is number n. Integer number. Alright, enter a number. So how you find square root? How to find? The most simple, straightforward solution is check every single number from 1 to number n. Alright. So you need to check all the numbers in this interval. Alright. So if this number power 2 is exactly equal to number n, alright. So we got the answer. Alright, we get the answer. Otherwise, what we want to do? Continue, that's it. Yeah. So when we stop, when we check all possible number in this interval. Alright. Okay, let's see. So we need a 4 here. 4. Let's say the candidate, for example, in range from 1 to number n. Alright. Is it correct? No, we need plus 1 here. Alright. Alright, so if the candidate square, alright, power 2 equal to number n. So we're going to write down solution is candidate, alright. And we break it means we do not need to move on anymore, alright. So let's see. Enter number n, and we enter number 9 here. You see that? Number 3. I want to enter number 25, number 5. However, if I enter number 7, what happened? Number 7 doesn't have a square root, alright? So it means nothing. However, I don't want to nothing, I want to bring out something to indicate that number 7 doesn't have a square root. Alright. How can I do that? Any idea? Do you know Sentinel algorithm? Do you remember? I guess you forgot it. Sentinel algorithm. You learn about it in the lecture 3, I guess. You can review it. But in here, let's use it. So I'm going to have a flat here. I assume that I can find a suitable square root number. So I assume it equal to 2. I'm sorry. Right now I'm assuming I cannot find. So it's 4. Alright. So when I got it in here, so I will turn my flat off, and I'm sorry, turn on my flat become 2. Alright. So after I go through the loop, I'm going to check it. If flat equal to 2. Alright. I'll write it down. Otherwise, cannot find square root for number n. Okay. Alright, that's it. So let's keep it. Enter number 7. Cannot find. Alright. Enter number 25. Oh, get solution. However, you don't need to have this one just if flat enough, because flat is true or false. You don't need to compare flat to true or false. Alright. It's similar result. 7, 25. That's it. Any question? No question? You can move on to the more sophisticated version, but I think it's enough to help you to understand. Here, this one is for find approximate solution, not exactly, but just approximately. Right? You can look at it at home. It's an advanced version, but similar idea. So let's talk about the new algorithm. We call it I section. So do you see? Can you see any problem with this solution? What is the most disadvantages in this algorithm? Why this one is not good? Alright, it's not good because we need to check all possible number. We need to check all possible number, all possible case. So you know something in programming, we always want to avoid this case because check all the candidates is a time-consuming task, and your computer will run it so long time. We don't want it, alright? Why we don't want it so long time? Because you need to wait, and usually we hate it, alright? So for example, if you type in something in Google here, I need to find something here, and you imagine that when you type in something and hit enter, and you need to wait 1 minute to get the answer from Google. So do you like it? No. So imagine that when you enter something to Google and you need to wait 1 minute to get back the answer. Do you still love Google? No. Yes, because 1 minute is too long. 10 seconds is too long in computer. Alright? So we want something faster. How can we go faster? How can we avoid to check all possible candidates? Any ideas? Alright? So we want to avoid to check on possible candidate. Alright? The most straightforward way to do it in here. I'm gonna copy this one. Alright. Copy, turn it out. So you can look at example here. If number n equal to 25, alright. So you're gonna check what? 1, 2, 3, 4, 5, 6. Do you need to check 6? Why you don't need to check 6? Alright, you do not need to check 6 because what? Yes, yeah, right, yes. Because 6 square actually greater than 25. It's means greater than number n. Alright, so it's necessary to check. Alright, so you can here. So if the candidate greater than number n, alright, so we're gonna rec. You don't need to move on, alright. But it doesn't enough. We want more faster. We want to become faster. So this solution is not guarantee a faster algorithm. So to become faster, to be faster, you will need binary search, or we call bisection. So how to do it? In here, one more thing you need to remember: the number has order. So what does it mean? Number has order. 25 here. So before 25 is 24, and 24 is smaller than 25. Similarly, after 25, 26 greater than 25. 23 smaller than 24. Okay, so we're gonna use this property to speed up our algorithm. Alright. So how to do that? Imagine you have a guest here. So you want to check. Alright, so imagine here we have a 25 here. So number n is equal to 25. So we want to guess. Alright, find a guess. But in here, instead of move from 0, move from 1 to 25, we jump in the middle. So we're gonna get is 25 divided by 2. So we get what? We get what? 25 divided by 22, we have about 17. Alright, 17. We get 17. But 17 square is greater than, greater than 25. Alright. You got it? Did you get it? You get it? Alright. So what happened? Because the 17 square already bigger than 25. So did you need to check any number greater than 17? No, yes, that's it, you are right. Because 17 square bigger than 25. So the bigger number of 17 still bigger than 25. We don't want it. We want something smaller than 17. Alright. So in here we have the guess here. So if the guess square bigger than 25, we know that the half before the guess here, alright, I mean the half after the guess here is not necessary anymore. So we just ignore it and focus on the half, the before half interval here. Alright, focus in this region. So we will have a new guess here. So new guess here is equal to 17 divided by 2. Alright, so we get smaller. Is equal to 8. Alright. However, 8 squared 2 is smaller than 25. Yes, I'm sorry. I 64. Now it's bigger. Alright, it's bigger. Now what happened? We still move to the back here. So we have a new guess here. It's a multiplied by 2 here. Alright. So we get it is 4. Alright. And 4 square is 16. And 16 is smaller than 25. So what happened? We move, we move to the first half interval. Okay, so that's the idea. It's the idea of the guess. Alright. So how to implement this idea? So you can see here, to implement this idea, you need have a low and height. This one is 2 pointer. Do you know 2 pointers? Do you know 2 pointer? You know it? How are you? You know it? Oh, you don't know it. I hope you know it. So we have a 2 pointer here, low and height. Alright, so we need to maintain here. Let's jump in the pseudocode. So we have a left here. Left, because our interval is number 1 and number 25. So left equal to number 1 and right equal to 25 here. And we have a middle. Middle equal to what? Left, right, divided by 2. Keep in mind here, this one it means we get integer only. Alright. Alright, so let's see. We have step 1. Step 1, left equal, which too long, let's say L for left. Alright. Is equal to 1. Right equal to 25. We have M equal to 1 plus 25 divided by 2 equal 13. Yes. But 13 square bigger than 25. So we do step So we're gonna remove because it's bigger here. It's bigger, so we remove the half here. We focus on this one. Alright. So it means that in here. So we remove this one. So I'm sorry. If in here, if you take the half here, if you take this one, because you have the high and low here, so you can right and left here. So if you want to take this one, you want to ignore this one, so you want to move to the low here. Right? So move from here. Move to here. Alright? And move to the next step. Alright, so now we have a new guest. The guest always in the middle. Alright, so we ignore the first half. And then we here. If you want to take here, if you want to take this one, you want to remove this one. Alright. So we move high to here, and we have a new guest, and then we ignore the half interval. Alright. So you see that we move cái này move to here. You see that? So low equal to yes. Alright. So in here, because they are bigger, so we want to ignore the bigger half interval. So we move right. So it means here, right? So now we have a new interval here. New interval equal to left equal to 1, but right equal to 12. So we reduce the search space, right? And then move to the step number 2. So we have a new, we still left is 0, 1, but right now equal to 12. So the mid equal to 1 plus here divided by 2 equal to what? 13 divided by 2 is 6, right? 6. And then we have mid 6 with square what is 6 square? 6 square, yeah, 36. 6 square. No. 36. I'm sorry, I forgot it. So it's greater than 25. Alright. No, I'm sorry. Greater than 25, so what happened? If it's greater, we still right here and plus 1 because and it become what? Mid 6 divided by minus 1 is 5. Alright, 5. So in step 3, we have an interval right equal to 1, right equal to 5, and mid 1 plus 5 divided by 2. What happened? It is 3. Alright. So m plus 2 is 9. 9 smaller in here. So what we're going to do? We want bigger. So left equal to. So it equal to 4. Alright. Alright, so we go to step 4. Oh man, number 25 too big. I should select smaller one. Okay, so we have a new interval here. Left equal to 4 and right equal to 5. So what about mid? Mid is left here divided by 2. How about this one? This one is 9. 9 divided by 2 is still 3. Alright, still 3. So this one is more than 25. So left should be bigger. So left equal to mid plus 1. Right, is equal to 5. So we go to step 5 here. So we have a new interval. left equal to 5 here, right equal to 5 here. So m equal to 5. Alright, so m square e equal to 25. So that's it, we got the answer. Alright, so that is the idea of bisection. Hay vui đi mới để hút. I'm just joking. However, bisection have another property, another application. It can sort element in a list. Alright, so we can sort element in a list. For example, you have a list A here, 5, 6, 19, 20, 23, 45. Hold on, 5 is here. So I have a target here. Enter a target. Alright, I want to know this target is a list A or not. So I want to use a binary search. So I want to confine my interval. The first one is the first index of the first element. It is 0. Yes. How about the last one? The last index. The last index will be equal to length list A minus 1. Yes, of course. And then we are going to check it. So because I move left from the beginning to the middle and the right from the end to the middle. So when they hit to each other at the middle, so it means I stop it. Alright. So right, left, smaller equal than right here. So I mean if they are still moving. Alright, because left it move from left to the middle. So it always smaller than right. Right, almost smaller, bigger. So when they are not equal, it means left become bigger, it means they are cross to each other. You see that? Move here and alright. So I'm gonna check it. So I have mid here equal to left plus right divided by 2. So if list A mid equal to our target, so what are we going to do? I will return mid. This is the position of element we want to get. I'm sorry, I cannot return here because I don't have a function when I rect. Alright. So let's see, I have a position here minus 1. It means I assume my element do not exist in list A. Alright, so position equal to mid here. That's it. Alright, so when I get out of my loop, so if this position is equal to minus 1, it means I cannot find. Right, let's say element, let's say target not found. Alright. Else, what am I going to say? I say found target at here. Alright. So let's escape it. So I want to find number 23. Oh, I'm sorry. I'm gonna take this one off. Alright, escape again. Here, 23 here, 23. Oh, alright. Oh, sorry. I forget the left and right. So if list here bigger, smaller than target, what I want to do, because it's smaller, I want to move to the last half, alright, smaller, alright, so I'm on the left equal to mid minus 1. L, it means it's bigger, I want to move to the first half, alright, so right equal to mid minus 1. Alright, that's it. Scale again. 23. Here, see that? 0, 1, 2, 3, 4. Add index 4. Okay. However, what happens if I change this one to minus 1 and 23 here? What happens? Let's see. I want to find 23. What's the difference between this one and the previous one? In here, I'm gonna copy it here. You see that for this one has order, but this one doesn't, has order. So keep in mind that even though boundary search is fast, but you need order. So every time you have order, think about boundary search. Alright. Okay, so let's assume I have a list of 10 million elements. Alright. Let's say I have 10 million elements. 10 million, 1,000, 10,000, 100,000, million, billion. That's only 10 million. And I want to search this one for 200,000 one. I mean 200,000 times. For in range, I want to search 1,000, 2,000. In here, and this is my target. Right, so let's see how long they're gonna take. Time here, start equal to time here, and equal to time here, and right now duration and minus r. All right. Do you think how long it's gonna take? Any guess? 20 seconds? 10 seconds? Who think 10 seconds? Who think 1 second? You have no idea? Okay, let's see. Now I should turn it off right now here. 4.6 seconds. Still slower than set. Set faster. Alright. For set, it's just less than 1 second. Remember set? For set, you only need 0.06 second. And here you need 4.6 seconds. Okay, so that's it for today. Any question? No question. So if you don't have a question for me, I'm gonna have a question for you.